Cool. And we are recording. And I will kick off the presentation here. So just as a few introductions, my name is Drew Gazowski. I'm a territory account executive here at Traefik Labs. Also aboard the call is Matt Elgin, who works closely with me in a solution architect capacity. If you were to fall out of space and have never seen Traefik Labs before, I want to make sure that there's a few verbiage and context things that you're aware of. It'd be very strange for you to fall out of space and just land in this meeting, but nonetheless, to make sure that everybody's on the same page. So Traefik Labs is an open core company. Our sort of flagship product, you might say, is Traffic Ingress. We have over 2 billion downloads, 500 plus contributors, and are working with hundreds and hundreds of thousands of machines in production. Some of our biggest users and customers are companies you've probably heard of before, Expedia and Lincoln Financial. Everything that we build at Traefik Labs sort of has three things in mind, right? And these three things are simplicity, automation, and cloud nativeness. I like to leave as a caveat here that though we are very cloud native in our thinking, we make sure that most of the things that we come off the production line here are also legacy friendly. A few terminology bits here. So the first piece of terminology is the individual products that we're using. The first is Traefik Pilot. Traefik Pilot is our newest product. And what Traefik Pilot is about is two things. The first is building plugins that allow you to manipulate traffic as they pass through a traffic proxy. The other thing is visibility and notifications over the network traffic in your infrastructure. I'm going to skip over Traffic Enterprise just for a moment here. Traffic Proxy, like I mentioned, is our flagship product. It acts as a reverse proxy ingress, and Traffic Mesh is a service mesh. What Traffic Enterprise is about sort of combining all three of these other products and providing, acting sort of as an older sibling for enterprise implementations, or if you have many traffic proxies, allowing them to work together. Yeah. So again, it's ingress, service mesh, and it also adds a layer of API gateway functionality. Just to visualize this a little bit, you're probably most familiar with Traffic Proxy. What Traffic Proxy does is takes traffic from the internet, hits the proxy, some logic's applied, and it goes to the service that it's determined that it's supposed to go to. What the Enterprise Edition of and this is sort of the middle bit of functionality here. What Traffic Enterprise Edition does is adds the notion of a controller, which acts as a control plane. That allows you to coordinate the activities of many traffic proxies, as well as allows you to implement enterprise middlewares, as we call them. An example of this would be, the Traffic Enterprise Edition middleware for rate limiting. And as an example, if you wanted to add a rate limit to service A, but you had three proxies stacked up in front of it, you could say, hey, controller, make sure that none of these three proxies allow the rate limit to go above 200 requests per second, as an example for service A. Okay, and just a full list of what it is the Enterprise Edition does and what we're going to be focusing on today. And the Enterprise Edition is going to be what we're focusing on today. Here's a full list of it. If you're especially interested in some of these features, maybe you can take a screen grab and talk to one of our salespeople about this, and we'll be happy to give you any sort of like documentation or context that you find interesting. But at a high level, we break it into sort of 5 buckets as to what it is we help people do, and that's traffic management, availability and scalability, security and safety, observability, and cloud native and migration. Now we're going to be highlighting a series of new features today, which are additional functionality for Traffic Pilot, custom plugins, OPA middleware, as well as multi-cluster Let's Encrypt. Matt's going to be leading the conversation on these. One thing that I encourage in all of my meetings is if you do have questions, if this was a sales meeting, I'd say make sure you make them known so you get your questions answered. But for purposes of the webinar, if you do have questions, please feel free to just submit the question and we'll get them answered at the end of the meeting. Don't wait to the end of the meeting where they might get forgotten or what have you. So, Cool. Matt, you good to, maybe I should stop sharing and turn the ball over to you?
Yep, sounds good. I will take over and hit share.
Cool.
Awesome. So like Drew said, today we want to spend some time diving into some of the new features that are introduced in Traefik Enterprise 2.4. So we're going to walk through an overview of each one of these features that you see listed here, as well as go through a short demonstration of each one of those. So before we dive into the first feature that we want to look at, which is the integration with Traefik Pilot, let's go over to a quick installation demonstration just so we can get our bearings around the environment we're working in and look at what that Traefik Enterprise installation process looks like. So we'll do that here. You can see I've got a code editor window up where ahead of time, what I've done is set up my environment variables to reference my license key and other variables I need. I've also pulled down the Kubernetes manifest file that I'm going to need to actually stand up the resources for the enterprise install. Once we have those, there are just a few steps to do. So we will create our namespace to run everything in. We're then going to mount our enterprise license key as a secret in Kubernetes. And now we're ready to actually deploy our resources. So there are two resource files that we want to actually deploy as part of this installation. The first one is the static config YAML file, which is mounting our static configuration and traffic as a config map. So this is a fairly standard configuration file at this point. We're just defining our entry points for 80 and 443. We're redirecting from 80 to 443 to only allow secure traffic. We're enabling our dashboard as well as using the Kubernetes CRD provider scope to a few specific namespaces. So we'll keep going through this file and talk through some more feature specific details, but that's enough for now to get started. So we'll go ahead and deploy those, both that configuration file as well as the Traefik EE YAML file that is standing up all of the custom resource definitions and the actual resources that we need to run in our cluster for enterprise. So we've seen all of that is now rolled out. So what we can do now to check the status is do a get pods and watch the progress there. So we can see all of our pods start to initialize and get up and running and get to a ready state. So in just a second, we should see that our controller is ready, as well as our proxies in our plugin registry. So we can now make sure that we've got an external IP for our load balancer that we can map to a DNS entry so that we can resolve the host name that we want to use. The last step that we need to do here is connect tkettle or tctl, our command line tool, to the cluster that we've just installed in Kubernetes. So we'll use those commands there and then verify that everything is good to go with a tkettle get nodes. So we've done that and we can see that we've got all of our nodes that we expect are up and ready to go. So with those few commands, we are up and running. We've got everything set up for our enterprise install. The last couple of things we're going to do as part of our setup process is install some helper services in the cluster. So we're going to do an example with authentication that we're going to use Keycloak server for. So we'll install that, as well as a Vault instance, which we're going to need for our multi-cluster Let's Encrypt example when we get to that. So we'll go ahead and provision both of those, and we should be good to go with our environment. So with our environment up and ready and everything installed in our Kubernetes cluster, let's start walking through the new features that we want to highlight. So we will start with the enterprise integration with Traefik Pilot. So the use case here is where we want to take advantage of the observability and customization that is provided by the Traefik Pilot service. So that's going to provide us things like the alerting, the metrics that are available from the Pilot UI, as well as access to the public plugins that are provided through Pilot as well. So that'll be integrated right in the enterprise dashboard, and we'll see what that looks like in a second. And the integration process is very straightforward. It's just a couple of lines in our static configuration. So let's now jump over to this example and walk through what integration looks like. So we will start with the first step, which is actually exposing our enterprise dashboard. So we will apply this dashboard.yaml file, and let's take a look at what the contents of that file actually are. So you can see it's a standard Kubernetes ingress route. So we are using the web secure entry point. We're using a host rule to match to the dashboard subdomain, and we're routing any of those requests back to our API internal traffic service. So with that deployed, we should be able to refresh and see that we can access our enterprise dashboard. So we see we've got our cluster information on any ingress resources like we get from our Traefik Enterprise dashboard. But today, what we want to focus on is the pilot integration. So we'll do that by going to the top right of our screen. And we see that the pilot UI folds out from the side of the screen. So we can now register this instance that we've just deployed into Kubernetes, again, by just adding these couple of lines of code into our static config file. So we're going to grab this token that's generated for us and put it into our static configuration YAML file. So we'll go back here, and if we scroll down, we'll see that we already have this section here as a placeholder. So we will just paste our new token into that section. We can then save that file and go back and do a kubectl apply of our static configuration. So we've done that, and it will take just a second for the new static configuration to be picked up, for the connection to the pilot service to happen. So what we'll do in the meantime is, as we start walking through the different pieces of the pilot functionality, we'll scroll over to another example account that we have that also has been running for longer and has some more meaningful metrics we can look at for the metrics side of things. So you can see from the pilot UI, we get this time series graph of things like the requests per second, both from a max and average perspective. We get the total requests over that time period as well. We also get request duration graphed over that time, as well as the open connections. So we can start to look at this. If we notice any outliers like we see at 6 a.m. here, we can use that as a point to start to dig in and troubleshoot, maybe investigate what's going on. We can also change the time window from last day to last week or last month as well, if we want to change our scope of what we're looking at here. So now we can go back to our current instance for pilot and see that the connection process has happened successfully. So we can see that our new enterprise cluster has been connected. We can start to collect those sorts of metrics that we just saw on our other account that we looked at there. The other thing that we can start to set up is the alerting features. So there are a couple of different alert types that we can opt in to subscribe to. So we can set up health checks on our instances, as well as security notifications in case there are any vulnerabilities that we should be alerted of on our instances. We can also specify what methods we want to use for the alerting, whether that's email or a particular webhook that we want to direct these alerts to. So with that, we've got our new enterprise cluster installed. We've got it connected up to our pilot instance with that integration from the dashboard. So the next use case that we want to talk about in 2.4 is the ability to leverage custom plugins in the plugin registry. So the use case here is if we have a certain custom bit of functionality that we want to introduce into our enterprise cluster that isn't covered by either the out-of-the-box enterprise or open source middlewares that are out there. So the way that we can do that is by leveraging the plugin capability in Traefik. And basically, these are going to get stored in a new plugin registry that is a node in the cluster. So we'll walk through how we can do both public and private plugins in Traefik Enterprise, as well as some of the new tkettle command line commands that have been added for interacting with this plugin registry for doing things like adding new plugins, listing plugins, deleting plugins. So let's take a look at this use case. And we're going to start out again in the Traefik Pilot UI. So you can see we've got a last tab here for plugins, which is listing all of the community contributed public plugins that are available in this list. So we can look at some of the examples for ideas of what's possible with this plugin framework. Some examples that are out here are things like the implementation of fail to ban for allowing or denying IPs, some orchestrator specific functionality for Swarm, header transformation. So lots of examples there on what's possible. For this demonstration, we're going to focus on this demo plugin, which is provided by Traefik as an example of the development process for putting together the Go code that's required to actually build your own custom plugin. So we can get some more information on that specific plugin there. But for now, let's walk through actually integrating these plugins. So we're going to go back to our static configuration file, and you see we've got a block for plugins already included but commented out. So we're going to uncomment this to enable it, and you'll notice that we have both a public and a private example that is part of this configuration that are following the same syntax where you're pointing at the module name and the version that you want to include. So we can uncomment this, and we will save our static configuration. So we can apply this configuration, but before that, we need to add our private plugin here. So the way we do that is through this create plugin command, pointing to the zip archive of our plugin code that we want to include. So we've just done that. The next thing we can do is update our static configuration to reflect the new plugins that we want to use. So we can verify that these have been added doing a tkettle get plugins. And we'll see at first that it's reflecting the private plugin that we just manually added, but it'll take another second for our public plugin to be reflected when that static configuration is applied. So we'll check our static config. We see that that plugin section still hasn't been reflected. So we'll give it another second. And we see that we now see our plugins in our static config. So we should be able to rerun get plugins, and we see we've got both of those that are now available in our plugin registry. So now that we've got those accessible, we want to test those out with a demo application. So we have a demo application that we're going to deploy into this Kubernetes cluster, and we'll first curl it without the middlewares, and then we'll add the plugin middlewares to demonstrate the difference. So let's take a look at the ingress route for the demo application as it currently stands. So again, we're using just a host rule that's pointing at that app subdomain. Currently, we've got empty middlewares. So what we can do is curl that application as is, and you see that it's just responding with certain headers and other information about the traffic that's being presented to it. So we can go back to our ingress route definition, and we can uncomment the public and private demo middlewares that we want to reference. And let's take a look at the actual definition here. So if you're familiar with the standard Traefik middleware syntax, it's going to be very similar, where we are using the specification to include any of the configuration details we need for that particular plugin. So again, in both of these examples, we're just adding a custom header as part of our plugin implementation. So let's update the app ingress route definition to reflect those new middlewares. We should now be able to curl that application endpoint, and we see that we've got a couple of additional headers that have been included, mapping to our private and public plugins. So with both of those use cases covered, let's continue to talk about middlewares here for our next feature, and let's talk about one that is provided out of the box in Traefik Enterprise in 2.4. So that is the Open Policy Agent integration middleware. So the use case here is if we want to leverage that policy as code idea for Open Policy Agent and secure our infrastructure with fine-grained authorization using that syntax, we can use this new Open Policy Agent middleware to do just that. So the way that it's implemented is, again, as a standard Traefik middleware. The specification allows us to use that Open Policy Agent Rego policy language to either embed our policy inline in our middleware specification, or to point to a bundle as part of the specification as well. So again, let's take a look at how this looks as an example. So we're going to use our same demo application that we were just using to walk through this example as well. So we will start by taking a look at the definition of our ingress route again, and we will uncomment that OPA middleware so that it is applied to our router. Let's look at our definition again. So in this example, we have the OPA policy embedded directly in our middleware definition. In this case, it is looking for a valid JWT as part of our request, and it is looking for a specific email value as part of that JWT. So let's test this out again, first by applying our new definition for the ingress route with the middleware. And let's start by trying to curl the application as before without any sort of token as part of the request. And we see, as expected, we get a 403 response. So let's now try to fall in line with the policy implemented and first grab a token from our Keycloak server and then curl this application with the authorization header. And you can see in this case, we've included that bearer token authorization header, and we're now getting the expected response back from our application there. And to wrap up the list of features in 2.4 for today's session, let's now walk through the multi-cluster Let's Encrypt functionality. So the use case here is when you start to manage multiple Traefik Enterprise clusters and start to want to introduce some efficiency in how you're managing your TLS certificates across those different clusters. So this is going to provide a way to easily do that. And what's actually happening under the hood is that this feature introduces a dedicated agent that is running in your cluster that is going to solve your Acme DNS challenges for those certificates. From there, that agent is going to store those certificates in a HashiCorp Vault store in a dedicated engine. And then your static configurations, your routers can then reference that distributed Acme certificate resolver like you can a standard certificate resolver in Traefik. So again, let's take a look at what that looks like in practice. So a bit of setup before we go into this last example. In order to test the multiple clusters, one thing we're going to have to do is have multiple Traefik Enterprise clusters. So we have followed the same installation steps we did earlier and installed a test instance of Traefik Enterprise in the same Kubernetes cluster in a different namespace. So we followed those same steps in terms of the namespace, the secret for the license key, as well as deploying those resources. So the next thing we want to do is enable a secret engine that is going to store our certificates in our Vault server. So we've seen we've just done that. So the next thing we can do is actually deploy the Let's Encrypt agent resources. So before we do that, we want to mount our API token for our Cloudflare DNS provider as a Kubernetes secret so that we can reference it in our deployment. So if we look at the details of that deployment, you can see that we've got this Acme agent deployment being set up that again is referencing our Cloudflare API token so that we can carry out those Acme challenges. We've got a couple of volumes set up for both the configuration as well as state that can be persisted across the agent restarts. We've got a service listening on a particular port, as well as a config map that is specifying the relevant configuration we need for this agent. So specifically, there's a vault section that is going to specify the location of that vault server, the authentication. So in this case, we're just using dev mode. So we're using a root token, as well as that engine path that we just enabled as part of the setup. The second piece is that we are setting up the certificate resolver. So it's a distributed Acme resolver using the Traefik Enterprise email pointing at the staging server for Let's Encrypt so we don't run into any sort of rate limiting issue. So we can go ahead and deploy that. And the next thing that we can do is look at our static configuration to make sure that we are referencing this agent that we're just configuring. So there are a couple things that we'll want to enable here. First, in the providers section, we'll want to set up a plugin for Vault specifically that is again referencing the URL, the engine path, the authentication. We will also want to reference our new certificate resolver of type distributed Acme that is pointing now at our Acme agent that we have installed in our Kubernetes cluster. So we've got that set up and should be able to now update our static configuration as part of that definition. And the next thing that we can do is now reference our new certificate resolver in that ingress route. So we'll first disable that open policy agent middleware so we don't have to worry about any sort of token in our request for this example. We'll now uncomment out this block in the TLS section where we're referencing that distributed Acme cert resolver we just set up in our static configuration, as well as specifying this wildcard certificate under that webinar subdomain that we'll be able to reference as well. So we can go back to our script. Before we apply this new definition, we will make sure that our static configuration has been updated. So we see that our new distributed Acme section is indeed in our configuration section, as well as double check our pods in this namespace and make sure that our Acme agent is up and running, which it is. So we should be good to go in terms of updating our ingress route definition with that new cert resolver. So we've done that. And what we can do to watch this in action is continuously curl that application endpoint. And what we're looking for here is watching the certificate information switch from the default Traefik certificate over to this wildcard certificate that we're getting through the DNS challenge. So it'll take a second for the agent to navigate that challenge process. So what we can do is check on the agent logs as well. And we actually see as we're pulling up the agent log terminal, we can see that our certificate has successfully switched over, but we can still take a look at the logs to get some information about the challenge that's happened, the certificates that have been provided as the result of that DNS challenge. So we can close out of both of these processes here and do one last verification step where we will want to take a look at what's in the Vault KV store, where we see that we do indeed have a key mapping to that new wildcard certificate that we've just set up. So the very last thing we want to do to test this out is make sure that we can use this certificate resolver across multiple clusters. So we're going to go over to our test instance here, and we'll apply a test version of our demo application that's referencing this same certificate resolver. So what we can do to test that out is curl the application here and making sure that we're using our test instance of Traefik. And what we should see is that we get the wildcard certificate back, which we do. So we see that we're using this across the multiple Traefik Enterprise clusters that we have set up. And with that, that brings us to the end of our presentation and demos for the day. So at this point, we can open it up for any questions that we have from anybody on the webinar.
Awesome job, Matt. That was really good presentation. So I only have one question in the box right now. Maybe I can leave a few moments for some other ones to come in. All right, well, why don't we handle the first one and we'll see if any more pop in. So the first one is, I'm new to Traefik. Can you outline the challenges between networking between traditional and containerized environments?
Sure. Yeah, it's a good question. So that's a use case that we run into a lot, especially in the context of companies that are in the midst of a cloud migration and wanting to, make sure that they can address both of those use cases, that more cloud native, the more legacy approach at the same time. So that is something that is readily handled by Traefik, and generally the way we see that handled is by leveraging multiple providers that can point to, for example, the Kubernetes CRD that we used in today's demo, as well as some of the other ones like maybe a file provider or other examples that can point to some of your more legacy applications. So definitely a use case we see all the time and something that's handled well by Traefik.
Next question is, only tangentially related. You guys are gonna give me a fit with these words. Only tangentially related. Is there any plans for a WAF plugin, or is this better implemented in front of Traefik?
So that's a great question. So I think at this point, that is something that would fall into a candidate for that custom plugin framework that we walked through as part of the demonstration. Certainly kind of a point that could be leveraging that point of extendability that the custom plugins are providing. So that would probably be the first place to look at this point.
And I could say anecdotally for that question, we get it all the time on sales calls. So certainly something that is top of mind of a lot of people. All right, next question. We currently use Traefik 1.x, which I love, but our IT ops guys are really pushing us to Azure Front Door instead. Any thoughts on how the two compare, pros, cons of each?
That's a good question. So glad to hear that you're on Traefik 1.x. To be honest, I can't speak specifically about the comparisons with the Azure front door. So it's certainly something that if you wanted to reach out and have a conversation about how the differences map to your particular situation, we'd be happy to follow up and kind of dig into that use case a little bit more. And kind of talk through what that would look like in terms of against a Traefik 1 or Traefik 2, and leveraging some of the new capabilities that are in the 2.x versions as well.
Yeah, one thing I can say sort of from a sales perspective on that is before you move anything to sort of one of the big cloud providers, I would say make sure you check the price before you do it. Typically, it's a lot more expensive, although it's not every day we run into Azure Front Door. Can the full stack of Traefik Pilot be run on premise, or only the hybrid approach with the plugin registry is available?
So currently, Traefik Pilot itself is a SaaS offering, so there's not an on-premise option for that. So currently, it would be if you are specifically interested in the plugin functionality, then the best bet would be to use that plugin registry capability that's been added to leverage that private plugin capability.
Yeah, and this isn't a shy crowd. The questions keep coming in. I find it really, and this is a fresh question, I find it really handy to use OPA. Do you have some performance benchmark to add middlewares, especially complicated OPA with many rules?
That's a good question. So I'm not aware off the top of my head of any specific benchmarking that's been done with OPA middleware specifically. I know in general, the middlewares are meant to be pretty lightweight and unobtrusive, but certainly something that we could check in on, what the extent of a performance impact might be by starting to introduce some of those more complicated OPA rules, as you mentioned.
Awesome. Well, that appears to be the end of the questions. Maybe I'll give it just a few more moments if somebody has something top of mind. So the most recent one I got was, what is the funniest mispronunciation of Traefik you've heard? It seems like no one at my company can say it right. I'm actually not sure I say it right myself, so I don't want to step on my own feet should like one of our executives say it a different way than I do, or perhaps the funny way I pointed out. But I'd say it's certainly up to interpretation exactly how it's said. I go with Traefik, which is the word traffic with a French accent, because we are, after all, a French company. So Traefik. But outside of that, yeah, that's what I got. Awesome, guys. Well, thank you so much for the time. Maybe I'll just make sure that I have like a full minute without a question so that nobody's like typing and it's abandoned. All right. All right, guys. Thank you so much for the time. I hope this was an informative session. I know it was a good presentation. So if there's any follow-up questions, I would like to direct you to our sales team or our support channel. We really do sort of take like these new releases and educating the user base really seriously. So I hope this was fulfilling for you guys. Thank you all. Au revoir.
Thanks so much.